Hey, this is Gavin King from windandsolarpowerfacts.com, and I just want to share a few more wind and solar power facts with you. First, the basics. Solar power is the result of converting sunlight into electricity. Most of us already know this, but some may not. Now, the question is, how is this done? This can be accomplished by using photovoltaic panels, or it can also be done by using CSP, which stands for concentrated solar power. What's CSP? Many folks out there wonder, but first I want to cover what photovoltaic panels are. They're sophisticated sheets of silicon-derived energy-gathering devices used to transform light energy into electrical energy. And CSP is basically the use of mirrors or other devices to redirect the sun's energy to a place or point, usually to heat water to drive turbines or generators. How reliable is solar power? There's a lot of questions about that reliability because the grid we have right now is fairly reliable even though it's inefficient. Solar power is reliable while the sun is available. Solar power is abundant and produces significant amounts of electricity during the daytime. Now, what happens at night? Well, when the sun's not available, the energy generated by solar power can be stored in batteries or other storage devices. So it may produce an excess or an abundance of solar power during the day, of electricity during the day. We can redirect that electricity to a battery during the daytime to store it, and then use it, re-access it again at night. What started solar power? Well, Auguste Muchat used a specially shaped trough to create the first solar-powered engine in 1866. And really, probably the concept was around for hundreds of years before that because legend has it that Archimedes used well-polished shields to repel Roman invaders. So people were aware of the power of the sun for centuries before Auguste Muchat. So it's been around, the concept's been around for centuries. So how does concentrated solar power work? The sun shines down and is reflected by a panel or mirror or a trough. The reflected sunlight travels through a lens that magnifies and focuses that energy, and then that magnified beam is aimed at a target that will convert that energy into another form, typically steam or heat. What good does all that do? Well, the heat that is stored and converted can be used to drive turbines or generators long after the sun's energies went down, creating a continual stream of energy. Now, what's necessary for this to happen? The most efficient and beneficial way to develop a continual stream of energy is for all nations to tap into the same network or grid. This grid would have to span international boundaries so that when the sun sets in one power generating sun zone, there would be others that it would just be rising in, circling the globe and capturing the sun's energy the entire time. Is this realistic today? Well, due to the limitations of boundaries and governments and national identities, a global energy system is virtually impossible, but may someday solve all of our energy needs. Again, this is Gavin King from windandsolarpowerfacts.com. Please log on to my website for more solar power facts.